Right. After we took care of the string columns of the dataset, we're ready to clean and pre-process the numeric ones. Let's start by displaying the dataset we'll manipulate, loan data numeric. Okay. The first thing we'll do is check if there are missing values in the array. We can go to a new cell and combine the isNaN function and the sum method. The output is 0, so we're good to go, right? Well, not really. Do you recall how when we split the dataset, we set all the missing values equal to temporary fill? Therefore, technically speaking, there aren't any missing values in the array. However, following the requested casting directions, we must substitute all those fillers with the worst possible values. All right, we'll do that in the next few minutes. Now, we'll display the headers to see what each column contains. The first one holds all the IDs for the different accounts. These are supposed to never be missing since they serve as an index for the other values in the row. To check if that's the case, we must be a bit creative, since we already explained that all the missing values are filled up. So we must check whether any of the elements of this column equal the temporary fill we define in the first part of this practical example. If you need a reminder, here's what this variable looks like. To check if temporary fill features in the ID column, we can combine the isIn function and the sum method. Just like isNaN, the isIn function will return either true or false for every element of the array depending on whether or not it equals the filler. Thus, the sum will express how many times this value features in the array, or how many times we have obtained true. The output is 0, which means we haven't had to fill any missing values in this column. Going back to header numeric, we then have the loan and funded amounts, the interest rate, the monthly installments, and the total payments. The only column where the minimum value can be considered worst is the funded amount. Hence, we must switch out all the fillers in that column for the minimum, while switching fillers in the rest with the maximum recorded value from each column. Lucky for us, during preparation, we stored all the min, mean, and max values in the temporary stats variable. So we'll take advantage of that. To revise its content, we'll call temporary stats in a new cell. We see many missing values corresponding to all the string columns we had at the start of the practical example. We aren't interested in such values right now, so we'll use indexing and plug in columns, numeric, for the second axis. We can't use header numeric because, unlike series, arrays only take numerical indices. Therefore, this returns only the statistics for the numeric columns. It's easy to see that the top row holds all the minimum values, the middle one, all the means, and the last one, the maxes. This is important because we'll be using temporary stats to substitute out all the temporary fillers. To avoid confusion, we'll refer to each of the three rows as temporary min, temporary mean, and temporary max, respectively. Therefore, all of the following columns can contain values between what we see in the first row and what we see in the third row. For example, the minimum value for the last column, total payments, can be 0, while the maximum value, $41,913.62. The loan amount can be of any size according to the bank's current abilities. The interest rate varies according to the loan amount and credit risk status of the individual or business taking the loan. The number and size of the installments will depend on the contract sign, while the total payment will obviously incorporate all parameters mentioned above and will certainly be the largest positive value of all in nominal terms. We said that funded amount is the only column for which we want to set the filler values equal to the minimum, so let's start with that one. Here's the relevant code. So let's go through it together. We set the funded column, which has an index of 2, to be equal to the output of NP where. The function goes through all individual elements of the array, and if they are equal to the filler, assigns them a more appropriate substitute from temporary stats. In this case, we'll assign the minimum, so we're only interested in the first row of temporary stats, which has 0 as its index. Otherwise, the individual funded amount retains its value. The last line in this cell displays the filled-out version of the column. All right, let's run this piece of code. Looks great. Before we move on, let's quickly discuss this expression, as we'll need it later on in our code. Temporary stats also contains the mins, means, and maxes for all the string columns as well, not just the numeric ones. Hence, if we display the fourth individual element of temporary min, which has an index of 3, we get NaN as an output, because it regards the string column loan status. Even though we converted the values of loan status earlier, we generated temporary stats even before that in the setting up part of the practical example. Thus, temporary stats contains no statistics for any of the original string columns. Going back to the syntax, if we add columns numeric in the index for the second axis, then we are referring to the min of the fourth numeric column. That's the interest rate. That's why we get an actual number as the output this time. The bottom line is, we need to help ourselves with the columns numeric array to properly indicate the desired temporary statistic while working with numeric data. All right. With that technique in mind, let's take the next step, filling out the remaining numeric columns according to the head of Data Analytics casting directions. For these 4 variables, in particular, we need to do so with the maximum temporary value rather than the minimum. To get the correct indices, let's once again call header numeric. The variables we're interested in appear in the second, fourth, fifth, and sixth columns, so they hold indices 1, 3, 4, and 5. Instead of typing out the where function 4 times, we'll use a for loop that goes through a list of all the indices. Then we'll paste the code we wrote for funded amount and change all the 2's to i's, or whatever name we've chosen for our iterator variable. Additionally, we'll pull values from temporary max rather than temporary min, so we'll change the 0 in the temporary stats index to a 2. This iteration produces no output, so let's go to a new cell and display the dataset. If we compare this to the loan data numeric at the beginning of the lesson, we'll see that the fillers in the loan amount and installments columns are substituted with more fitting alternatives. Thus, it looks like we're making valuable progress. Fantastic! Let's wrap it up here, and I'll see you in the next lecture.